This conference will now be recorded.
Okay, hope you all can see my screen. So Vijay garu, are we good to start or are we waiting for anyone else?
Uh, hi, sir. You can start the session.
Okay, thank you. Okay, before we get into the actual topic, which is AWS, just want to take you all through what is basically the fundamentals of various computing layers and what is a cloud computing and what is the primary difference between the software as a service, platform as a service, and infrastructure as a service. Then we'll see what are the offerings that AWS will do. Okay, and we'll see how we are going to leverage some of those services. Okay, so do we have anyone who's from non-IT or has never worked in any uh, software project? Just wanted to get a pulse. Okay, so I'll assume everyone has some basic understanding of how the software is getting developed and everything. Okay. So if you want to just understand, okay, what is a cloud computing? Okay, and I usually prefer to go to Wikipedia and then understand the basics or the fundamentals of any topic. Okay, before it actually gets into the tools. Okay, so if you look at any software application that you're developing or you're using, okay, there are three fundamental things in that entire application. One, the application itself, which is the features and the basic calculation, whatever that application is offering, okay, or whatever the feature that application is offering is at one layer, which we typically call it as application layer. So it's about what that application is known for. Okay, it can be a financial application, it can be a monitoring application, or it can be a communication application, just like the GoTo that we are using. Okay, or a collaboration application, just like your SharePoint or Confluence. Okay, or a content, just like your website. Monitoring is nothing but any one of these monitoring applications where you will be able to see, like just like your health of your laptop or just anything that you are using on your mobile, anything, any financial calculations, all this stuff. So those are the applications. But in order to run this application, you need to have something called platform and infrastructure. Okay. So platform is something, let's say you are using an application, but that application should be deployed onto a platform. So let's say you wanted to run a web application, which is a website that you have developed for your customers. That web application will not directly run on its own, but it needs to have a web container, okay, or something like a middleware, let's say a Tomcat or a WebSphere or a WebLogic, something like that is required in between where it can run the application. Okay, so if you are familiar with Java, it is nothing but the Java virtual machine, but with a lot of additional things, okay, involved in it, where in that platform, apart from your application code, all other dependent things like where are you going to store your objects, where are you going to store the data that you are going to consume within that application, and also how are you going to really multiply this particular application's capacity into multiple instances, and load balancing and all this stuff will be taken care by the platform. And how are you going to communicate between the applications? That is nothing but queues basically. So let's say you one application want to talk to another application, there are multiple ways. You can directly put a REST API call, or you can actually do an asynchronous communication if it is not a real-time communication that you need, which is through any of these MQQs or Kafka, these kind of facilities. And of course, every application will need to depend on a database where it is going to store the data required for that particular application. That's what is called platform. But even this platform, okay, needs something which is the primary thing, which is called infrastructure. Okay, so the infrastructure is nothing but the hardware, the compute, the networking, like the connectivity between all this hardware, okay, and the storage, basically, where you, if you have a lot of compute, lot of storage, okay, the backend storage, just like your hard disk kind of a thing. So in general, in any organization, you will always have this primary infrastructure already set. So based on your application type, on what your application need, you will choose your platform, and of course you will develop what are the features required for your application. Okay, good. Then what's wrong with this setup? Any organization can buy whatever the compute they want, whatever the block storage or the entire networking. They can build their network, they can have their platform, they can build their own application. But the biggest problem is, okay, that cost that is getting involved here. So let's say you have a small company, okay, and you wanted to develop your own application. The kind of investment that you need to make to develop even some simple one or two applications is actually huge, because you need to have your own computing server, you need to have your own platform and all the licenses required, and also you need to develop your own application. Okay, which is going to be huge cost. And but the biggest question is, okay, the cost is okay, but are you literally using this entire compute, entire network, or the platform 24 by 7, all 365 days? The answer is no. The company might be using hardly for 8 hours, or maybe some portion of this entire compute that what you want. Simple example, we are like 22 people on this call, right? And each one of us have our laptops in front of us, and I'm sure each of our laptop configuration hard disk is minimum 1 terabyte. Okay, your RAMs may be like ranging from 4 GB to 16 GB, whatever, or 32 GB if you have a high computing device. Okay, and a lot of other things, right? So, but what is the percentage at any point of time that we are using from our hard disk or our RAM or anything? So hardly like 10-20% of that hard disk, unless until I download movies, I don't even use 10-20%. Okay, but the remaining 90% or 80% of that entire compute is basically unutilized or can be optimized. Okay, so let's assume all 22 of us are connecting to a central platform or infrastructure. Okay, with all 22 different logins, but using a 1 terabyte hard disk, and maybe RAM can be increased, okay, shared among all of us. Then imagine we are going to reduce almost 80% of the computing cost, the infrastructure cost. It is just sharing this between a small 20-member group. Okay. So the cloud computing became very famous because of that. Even before it gets to cloud computing, we actually used to call, okay, this is as virtualization, virtual computing. Okay, you might have heard about virtual infrastructure, okay, virtual servers and all these things. In general, organizations within their own company, like you have a large organization, they have thousands of people working for you. That virtualization helped them to reduce the money that they're going to spend, okay, on all this infrastructure, and also it helps them maintain all this infrastructure in one place versus individually connecting to each and every laptop. So one of the shift is, the traditional days, any company used to give the laptops or desktops to their employees, and if there is an issue in your laptop or desktop, okay, they need to come and visit to the physically that place and then see what is the problem and then fix it. Now, because of the virtual infrastructure, you're going to just call them and then tell them, I have a problem with my virtual server or my VDI session. Okay, then they can run some checks in the backend itself, sitting in their own office or cabin. Okay, and they can actually fix it in the backend. Or if something goes wrong, they can give a new instance on the fly, and then they will just drop the old instance. So that is how the computing has shifted. So multiple advantages, not just only the cost. Cost is definitely the biggest factor. You're optimizing a cost a lot. The second thing is basically your maintainability, and you are not worried too much about okay maintaining each and every piece of your entire infrastructure and platform. Let's say you are a company who's expertised in developing some applications. But you don't need to spend too much time, energy, and the employees on platform, infrastructure, and all these things. What you can do is simply go buy a service from any of the cloud offering companies. Like, give me a platform where I can deploy my application, or give me the infrastructure. I will just take care of my platform and application. Worst case, if you don't want to develop an application, but you have a good customer base, okay, you can just consume that as a software as a service. So even the application is developed by someone, but you're going to use that application. You can get the customization and everything, but you are going to sell it to your customers. So those are the three different types of services. So let's say if an organization is providing you a common shared okay infrastructure, okay, for so many companies outside. It's not just one company outside, and you will never know where this infrastructure exists, and you don't need to be worried about okay, is my infrastructure in my data center or in my server room or on my desk. Okay, if you are not like you're not supposed to worry because this is actually provided as a cloud service by some company, and that is a shared one. That same cloud or the same infrastructure might be getting shared with other companies or other users of that particular cloud offering. Okay, so that is called infrastructure as a service. Okay, second one is okay, good. So you are not just giving the compute, but you are also giving the database required, the middleware required, and all the configuration required for the databases, middleware, queues. Okay, identity and access management. Okay, basically any application you don't want to keep that application completely open and free for everyone, right? You definitely want to add some identification law that can also be applied. That, along with the networking and computing and everything, is called platform as a service. You just take your application, what you have developed, deploy that application. Okay, just see if you want to do an application level configuration a little bit, and that's it. You will be ready to get your end users use this application. That's application as a basically that's called platform as a service. So there is something called software as a service also. Software as a service in the sense even the application is not developed by you. That is actually consumed by you as a service, just like what we are already doing, right? Like maybe in your mobile you have apps, app stores, or on our laptops you have a lot of these applications, including the one that we are now talking on, which is GoTo, and all our Microsoft application, any of these things. These are actually nothing but application developed by someone, but we are just consuming it actually. Okay, but consuming that application, I can create a lot of other outputs actually. Okay? So that's called software as a service. So that's the three layers, okay, that usually any cloud offering can do. And now recently there are additional things, something as function as a service, okay, container as a service, and all these things are actually additional flavors within the application. They're bisecting actually. So in an application you can have multiple features, but if you feature each feature can be a separate service, that's called a microservice. Or you can actually say each function in a particular feature can be a service, then that's called a function as a service actually. Okay, so it can do just only one function, and you can basically pay for only that function rather than entire application actually. That's what the service offering means. So we will get to that later. Okay, so this is what is overall basically an application infrastructure would be. Okay, and how a cloud offering is going to help you optimize the cost, maintainability. Okay, and a lot of other advantages of actually sharing this entire thing. So as I mentioned, infrastructure as a service, platform as a service, okay, and software as a service. These are three dimensions. If you are using a mobile backend, serverless, or function as a service is another thing that you're going to use. That's one thing. And another thing that we should also talk about is the cloud deployment types. Okay, good. So now that we understand, okay, what does it mean by all these three different types of services? How this cloud can of works actually. Okay, let's say you already have a company, you already have some internal applications. How can you get advantage of this cloud? And sometimes it's very important to reassess what is the type of data that you handle with. Let's say you have some PII data, which is personal identification data, and also some confidential information that you cannot share, you cannot put in public cloud. Security has been one of the major aspects anytime that you wanted to go for cloud, right? You can choose between a private cloud and a public cloud. So, private cloud in the sense you are not actually sharing that particular cloud with any other company. You have your own cloud within your own organization's data centers. Okay. For your employees, they don't know where their application exists. Okay. But at an organization level, everything is in your control, in your own data centers, in your own private network. That is called private cloud. Whereas you are just buying a service from like Amazon, Google, or Microsoft. Okay, then it's a public cloud. That means they are actually offering you as a service, but their cloud offering is shared by a lot of other companies, hundreds of companies actually, and you will never know where exactly your application or your data is getting stored. Okay, even though they'll give you some virtual services and all. And you can also do a combination of it. Let's say you have 100 applications, only 10 of them are highly confidential, where you have some confidential data moving in these applications. Then those applications you can deploy on private side, and the remaining applications you can put on the public cloud to take advantage of this costing and everything. And at the same time you can make sure these applications are talking to each other. Okay, like one application in the private cloud can also talk to the public cloud and vice versa. Okay, so that is what the cloud offerings, that basically the models. And when you say both public and private, it is called a hybrid model. So you have a private cloud model, you have a public cloud model, and you have a hybrid model, where in a same company both private and public offering can coexist. Okay, so that's the computing types that basically the various clouds are offering. Okay, and one of the things that we need to look at, okay, is the security aspect of it, right? Okay, security and privacy. So we need to make sure we are reviewing each and every applicant. Usually, every organization will do. There will be a huge checks and balances, like a huge list of checkpoints. Every organization will go through before they agree to put it into a public cloud. Okay, because of not only just the sensitivity of the data or confidentiality or privacy and all these things, but there are some lot of regulatory issues also. Okay, so for example, in India, if you wanted to keep any data in any of the India data centers, then by default you are actually coming under the scanner of, okay, uh, DSCI, which is an ASCOM body, where Data Security Council of India. Okay, and that will actually ask for, okay, what's this data? Where are you storing? Okay, and what if this data is lost? So you need to give them some audit requirements or audit proofs that these things are confidential, and how they are going to maintain, how you're going to maintain the resiliency and all this stuff. Okay, so these are also taken care by some of the cloud offerings. Like for example, if you go for AWS, and you can choose what is the region that you wanted to put your data, and by default they are going to comply with those regional, okay, regulatories. Okay, so let's say you choose North America Eastern Data Center, all the regulatories required for the North America Eastern location will be taken care by Amazon. So that's another advantage actually, and this is a huge task. It's not just easy, just like developing an application. Some of these regulatory things will like eat up a lot of the time the organization is going to spend. Okay, so that's another advantage. So if you look at some of these things, okay, and you have various layers where you are actually going to look at. Okay, one is you are going to have some clear agreements and supply demands even from a third party application that you are going to use. Okay. And so there are still limitations for the cloud, of course. Okay. One of the limitations is actually your maintainability is definitely going to get better, but at the same time, it is more and more, it will become like a black box for you. The reason for that is, let's say You have your own compute, you have your own applications on your own infrastructure, your own data centers. Let's say there is a production incident. Okay, your own team, your organization's own team can go log in and check the logs and see where the issue is, and they can fix then and there. But when you are taking an offering from someone like AWS or any other cloud, okay, then the biggest issue is where these logs are, where your actual data getting stored, okay, is a complete black box for you, because it's because of cloud, it's not visible to you and it's not shared with you. Okay, and even though there are some UI related stuff that will be shared with you to maintain your application, there will be some standard monitoring that will be able to help you to fix this. One of the biggest advantages is that, okay, one thing is just like our normal things. So the way it is going to work is, let's say your phone is not working, you can just go get a new phone. That's how these clouds will work. But whereas if you want to fix the same phone, you don't know where are the internals are actually. So that's the problem. That's one of the things that you will have an issue with the cloud. Okay, but when you compare with the cost saving and the time that is going to reduce for the maintainability, okay, and all other things that will take care in general, okay, it always has the advantages. Okay, so this is what is actually called a cloud computing. Okay, now if you want to understand this in a very simple fashion, okay, this entire cloud computing, I have just a reference to something called pizza as a service. Okay, so just a reference point, okay, to keep or make ourselves understand it in a very simpler fashion. Okay, don't read too much into it. Okay, just try to understand at a very high level. Okay, so let's say, excuse me, let's say you have you want to eat a pizza. Okay, one of the options is that you prepare each and everything at home. That means all the ingredients you are going to prepare at home, and you're going to use your own kitchen, and you're going to use your own oven to cook that, and then you're going to use your own dining table. You put your own drinks on top of it, and you're going to enjoy the ambience of your home. Okay, that's what is called on premises. That means everything in your own control, everything in your own place. That's is called the traditional way of actually computing, which is on-prem computing, which is not cloud. So, but another way of doing thing is you can actually take all the ingredients from outside. Like let's say if you go to a supermarket, you can get the pizza dough or all the sauces, toppings, and everything from the supermarket, and you just prepare the pizza in your kitchen platform, and then you're using your own infrastructure, which is your own dining table, and of course if you want to have a drink on the side, that's basically is called, you are getting actually, this is called, here it's calling as kitchen as a service, but if you look at the other way around, okay, then it is basically what you are providing is basically infrastructure as a service. So infrastructure, everything is taken care, okay, only the remaining all, okay, is okay, the infrastructure in the sense the basic ingredients to that one. Okay, next one is you can as well order your pizza, okay, from, let me give you this additional things actually. So you can order as well a pizza from your Swiggy, Zomato, whatever, okay, or the regular apps. In that scenario, you are not even preparing the pizza, okay. So it's basically your uh, you, not even the ingredients, not even the preparing of the pizza, everything is prepared coming to you, but you are going to sit on your table and then have your own home ambience, enjoy it actually. So that you can take it as a platform as a service. The other thing is you can as well drive through a nearby pizza shop, have it order and have the pizza then and there itself. That means even your dining table and other things are not required. You are actually enjoying the ambience of that particular pizza shop. So if you apply this analogy, okay, to basically what are we offering, okay, then it will be easy for you to understand. Okay, so if everything is in house, okay, that's completely on front. Okay, and if it is basically what you manage versus what the vendor manages basically. So if it is only infrastructure that you are providing, this is infrastructure as a service. If it is only platform along with the infrastructure, then it's called platform as a service. And if it is the entire thing, okay, that means you're just going and consuming that as a service, okay, and it will be software as a service. Okay, so this is just a reference point if you want to understand this. Okay, but yeah, just go cloud. Basically, the cloud computing in Wikipedia is good enough. Okay, for anyone to understand. And if you wanted to look at some of these additional things, what are we are using in a live facility, okay, or maybe let's say you wanted to use this. So you have this Microsoft Azure and Microsoft Office 365. I don't know if anybody of you are using Office 365, which is actually a good facility. All your Microsoft Office related tools are integrated and they're offered on cloud actually. So that's actually a true software as a service. So you can use Microsoft Azure or maybe AWS for that matter, okay, as an infrastructure. That means you will just get only the computing and virtualization, or you can use it as a platform. That means you will get the middleware and operating systems, everything on top of it, okay. Or you can get the complete software, just like your Office 365, where it is on a cloud, and then you will be able to use it seamlessly from any device that you own, actually. Okay, so that's the advantage. Okay. So now let's get to AWS. Okay. So AWS is one of those cloud offerings. Okay. So you have hundreds of cloud offerings. If you want to just look at this, um, there are, like, you can go to cloud-based information. Okay. You can look at various patterns. Okay, these are various cloud patterns that you can look at, and what are the various vendors that you can actually see. So one primary thing is elastic infrastructure, how the platform is going to work. So another thing is how are you going to offer storage and the communication. There are so many things actually. So let's not spend too much time here. Let's get directly into AWS in the interest of time. So AWS, as you know, like it has multiple things to do. Okay, one of the things is basically its cloud computing service. Okay, so the cloud computing service division of AWS has lot of offerings that it does actually. So including software as a service, platform as a service, infrastructure as a service, Lambda, which is called function as a service recently. Okay, and you can actually imagine, and it has something called EKS. Okay, Kubernetes service or a container as a service also. Okay, so there are so many services available. Okay, so in order to understand, okay, what are the various services in general when you're learning AWS cloud, it's something what you need to do is, okay, how are these services work? What are the various services that AWS is offering? As long as you know what are the various services, what each service is done, so you are good to actually become a cloud practitioner. So if you wanted to do some certification on AWS, and usually a lot of people are nowadays doing the certifications, right? Okay, so if you go to AWS certifications, okay, you have basic at high level. There are three different levels of certifications. One is the practitioner, second one is the developer associate, third one is a solution architect. Okay, so these are three levels. So practitioner is something, the basic understanding of all the services, okay, that every user of these applications will need to know. Okay, that means irrespective of you're a developer or you're a SRE or you're a production support or you are something into compliance regulators or any other role, practitioner is something the basic for everyone. Basically you need to understand what are the various services provided by AWS. Whereas associate, okay, and solution architect at a different level. Associate is someone who consumes the service on a daily basis. Architect is someone who can recommend what is the right services also, okay, from various aspects. So that's where you have, and you can start wherever you want. You can directly, there is no rule that you need to start only with practitioner. You can directly go to solution architect if you are already playing that kind of a role. And there are DevOps engineer, and they're specific to data and specific to machine learning and specific to security specialist and all this stuff. Okay. So yeah, the order, if you want, practitioner, associate, and architect is what I would recommend. And you need to prepare well, and you need to pay some fees, okay, if you want to apply for a solution architect. Okay, so let's get into the Aws console. Okay, and then you will be able to understand, okay, better on what are the various offering. Okay, so if you get into Aws console, and I can just say log back in, or you can just say sign in. So everyone must have an account in order to experience this entire thing. So I would recommend, if you don't have an account yet, just go create. It's a free account. I think basically, but you need to provide your credit card details. Okay, if after your free 750 hours, if you are still consuming some services, you will get charged. Okay, so for that you definitely need. Uh, I'm trying to log in, okay, to my account. Let me see. And one of the important points is that don't leave any of the instances or services that you're using open. Make sure they're shutting down whenever you're logging off. Otherwise, you will get charged. Okay, so there will be charge always. Okay, that, so right now I don't have any charges. Okay, but usually you will be able to see the entire cost and usage information, okay, for all the previous ones and everything here, okay. And sometimes if you just leave it, then it is going to be a huge cost for you. The moment you realize, okay, it will be out of your control. Okay. I think nothing in August, yeah, maybe that's good. Okay, so yeah, we will come back to this cost management later. I just wanted to give you a heads up that, yeah, make sure you are not running any services and everything. Okay. So if you click on this AWS icon, it will take you to the main homepage of the console. Okay. The first thing is to understand complete AWS. You start with this welcome to AWS, getting started with AWS. Okay. And this is basically your entire reading material. Okay, this is good enough actually for anyone to understand AWS and all the services, okay, that they are offering. Okay, so AWS overview will give you basically, again, I think the same things that what we talked about. What is a cloud computing? Okay, and what are the advantages of cloud computing, and especially what is AWS cloud? Okay, and how it works, and what are the various locations it has? Okay, and you have the same thing, on-premises and cloud computing. What are the pros and cons between on-prem? And we just talked about these three things: infrastructure as a service, platform as a service, and software as a service. So you can just go through this one, and general global infrastructure of AWS basically. So what are the various locations where you have AWS data centers? Okay, and in India we have one in Mumbai already, and one in Hyderabad coming up soon. Okay, and that building the huge data center, okay, here. So these are various locations where you can actually choose. We can choose, as I mentioned earlier, you are supposed to pick whatever you want, which region your data is going to be kept and all. Based on that, all your regulatory things will be applied. And there are various tools that AWS offers to interact with the AWS. It's not just to consume, but just to interact with the AWS. One is the console, what we are looking at right now. Okay. And the second one is your command line interface. You can actually download AWS CLI. Okay. And you can, through commands itself, you can actually achieve whatever you want. You can spin a new instance, or you can spin some new services. You can actually increase your elasticity, and all this stuff can be done using command lines. This is actually a very good advantage if you are into a team like IAC, infrastructure as a code, where for your own applications you wanted to scale up and scale down. Okay, some of these features offered by public cloud actually, so there you can directly interact with the CLI. Same thing if you want to develop any kits, you have SDK, okay, AWS SDK, and you have your own IDEs also. Rather than this console, you can actually have your own IDE where you can develop, okay, the cloud-based applications then and there. Okay, so if you are someone who's actually a developer, okay, or someone who's into this infrastructure teams and wanted to be an IAC working on something like related to IAC, then you can leverage some of these tools, CLI, IDE, and SDKs. Okay, and these are the languages that you can use in those SDKs. Okay, and as I mentioned, infrastructure as a code. So what is infrastructure as a code actually? Before let's spend a couple of minutes over there, right? So infrastructure as a code is nothing but, let's say you wanted to, in a traditional way, when you have everything on your on-prem, that means all the servers and data centers, everything is in your control in your own offices. Now you wanted to buy additional servers. Let's say your customer base has increased. Initially, you thought you will have 1 million customers. Now it went up to 2 million customers, and the performance started degrading for your application. Okay. Now you wanted to add more servers to it so that you will be able to support these additional customers that you got, and you wanted to add them into the load balancers where your applications are. So in a traditional way, if you wanted to get a new server added into your load balancer, it is going to take minimum 6 months to a year. The reason for that is actually the moment I realize, an application owner, I realize that okay, my application needs extra compute. I need to put a proposal, I need to get the budget approvals, and I need to then put a purchase order. Usually with one of the infrastructure provider, basically, let's say I want to buy a HP server, I'll put an infrastructure order. They will take a good couple of months to deliver that particular server and anything to my place. Then I need to send an engineer who can install all the operating systems and the libraries and the platform required for that, test it. Then they will actually connect to the entire infrastructure, okay, the entire network, and then I'll be able to see this in my network, and then should be able to add to my load balancer, and will start using that, okay, for my application by deploying my application. This entire process will definitely take 6 months in general if you are everything on-prem. Okay, even if you want to make it very faster, it will be definitely taking a couple of months, right? This entire time that you are spending in this entire thing, you are going to lose your customers. The moment you have application latency, application issues, what happens? So your customers are not going to stay there, right? So obviously they're going to look for another alternatives, okay? Or they will actually be unhappy with what the service that you're providing. But how can we make sure this entire computing thing, okay, this entire process, which can take a couple of months to 6 months, can be done within hours or if possible minutes, okay, is what the biggest advantage of actually the cloud computing. Okay, so another thing, EC2, like if you have heard about Amazon's EC2, elastic computing, okay, is basically nothing but, let's say you are using 10 servers and you want to use 15 servers from this moment because you are expecting more customers from this next hour. You can get those extra 5 instances within fraction of seconds actually. Okay, so that's what is called elastic computing. Okay, so with a single command or a couple of button clicks, you will be able to add extra, and even you don't need to click a button click actually. In AWS will provide a facility called elasticity, where you can mention, okay, I'm using 10 right now, but you can go up to 25, but in the increments of 5 at a time. Whenever I have more load, you can automatically add another 5 servers, so you don't need to wait for a command or a instruction. So you can go up to, and of course there will be a maximum cap, otherwise you will be get charged unnecessarily, right? You can say, yeah, maximum go up to 25. Okay, similarly, when there is no usage, when no one is using even all this 10, come down to up to 5 actually. So you can define the ranges. What is your bottom and what's your top, okay, and what's your mid actually. So in general you're going to pay for your mid, okay, but whenever necessary it can go up, and when it is not utilized to 100% it can go down also. All these things are actually to save cost, save the compute that you are using actually unnecessarily. Otherwise unnecessarily you're getting charged for the entire compute, okay. That's another thing that AWS provides. So in general, any cloud services provides, right? So infrastructure as a code is something like how can I programmatically can interact with this cloud offering? Okay. Let's say this entire logic, or maybe let's say I wanted to do a testing of my environment or testing my application. So can I just go ahead and then create a new instance for my testing? Before my testing starts, I wanted to create a new instance, deploy my application. After the testing is done, I wanted to just kill this instance actually, or just shut down this instance actually. If in a normal traditional way, that is not possible because you have a dedicated testing environment. You are paying the cost 100% of the time, okay. And whenever your application you wanted to test, you will come and deploy your application there. You will get your testing done and then move on. That's it. But here, you are getting an environment on the fly when you need it actually. So when you want it to get tested, then only you will be able to spin your environment. And after the testing is done, you can just shut down and you're going to pay for only that time. It can be an hour or a day or a couple of days. When you have been using this particular instance, you're going to pay only for that time. So the advantage is that instead of paying it for the whole 365 days, you're just paying when it is required. That's it. Okay. And as you're sharing with a lot of other users, the cost is also going to be very, very low for that particular time. Okay. So that's what is called infrastructure as a code. And if you are working in infrastructure code, that means you definitely need to know how you can interact with this offerings programmatically. And if you might have heard about Terraform, is one of those good config management tools. So there are some tools like Terraform, Chef, and Puppet. Okay, like well known, and of course Ansible is also another good thing. Okay, these are the tools that will help you to interact dynamically with your configuration, irrespective of any environment. It can be production also. Okay, so what they will do is they will be able to dynamically change your configuration on the fly when even the environment is running actually. So these are the advantages, and you can leverage one of these tools to interact with your cloud offerings and then increase, decrease, or any other thing. Sometimes you may wanted to send different configurations to different instances, like that also you can do. Okay, so that's another thing. Infrastructure as a code is another offering by AWS. And well architected framework, because one of the biggest concerns usually people will have is about the security, performance, and all these things, right, when you go to cloud. So AWS has primary focus on all these 6 elements. Okay, so one is operational excellence. Okay, operational excellence in the sense any issue that you are facing when you are having an application on the cloud on AWS is that they have a dedicated team to take care of any issues, be it with the compute, any issues related to application. Again, you are supposed to take care of that. Okay, but anything related to the infra and the platform, whatever they are offering, okay, will be taken care by them. There will be a dedicated support model for that. Same thing, the security, they have various layers of security. You can just click on each one of these things and then you'll be able to understand, okay, okay, what they're offering in each of these things is. Okay, so you can actually say operational excellence, click on operational excellence pillar here. Okay, and you will be able to understand what do they mean by operational excellence. Okay, and how are they going to help. Okay, um, and what are the various design principles they have. Okay, so and what is the basic definition. Same thing. Okay, you have your organization priorities and everything. Okay, so I'm not going to read all this, but you just you can actually spend some time reading this. Okay, so that you will get a better understanding of. Okay, so what are the various things that they will consider? Let's say security fundamentals. What are the various design principles they will consider in security so that it is going to protect the data? Okay. So every organization has various levels of defense, okay, how they are going to protect. And some organizations will range up to 7 different levels of defense actually. Some will start with 2 or 3. Okay. So it depends on what are the various levels of security protocols that you're applying actually and all these things. Okay. So yeah, and what are the various governance risk levels, okay, that you're going to apply based on your application type and based on what type of data that you're using within your application. All these things do matter actually. Okay, so we can get deep in the actual course on some of these areas. Okay. Um, and you can also talk about the reliability actually. So good that I have deployed my application. And how reliable is your platform? That means what if your platform goes down tomorrow? What if your platform is going to wipe out my entire data and application for good actually? So what's the guarantee? Okay, so this is something that AWS is providing you, the architecture and the details around it, on how reliable their services are. Even though there are a couple of instances where AWS being down, okay, but yeah, when you compare with a lot of other offerings and including your own on-prem thing, it's pretty highly reliable actually. So look at the reliability percentage they will be able to share. I think um, I'm sure there will be a public information reliability percentage. 99.99%. Look at this. So that means your services are available 99.99% of the time. This is actually the guarantee that they're giving actually. So, and this is what is called actually a service level objective, or in general, if you anyone of you are aware of the SRE terminology, site reliability engineering terminology, this is what the guarantee any company will give. Okay, that I will make sure I have my service available 5 nines, 7 nines, 10 nines, something like that actually. So this is like how many nines is AWS? Okay, it is called 5 nines. 5 nines means okay, 999 point. Look at this, 99.999 percentage. Okay, I cannot have 99.999 point, but 99.99 percentage is 4 nines. 99.999 is called 5 nines. So this is the percentage that exactly what AWS is offering. Okay, okay, for their service reliability actually. Okay, so and yeah, it's mentioned actually in their documentation also. So this is another thing that they are going to guarantee. Okay, so in a year, what they are saying is when they say 5 nines, in a throughout the year, like means 365 days, 24 hours, like all these seconds and everything, only 5 minutes they are presuming that their services will be down. Okay, of course, based on the type of service actually, that they have different nines. Okay, if it is a batch processing, data extraction and transfer loads, they're giving only 99%. That means they are taking extra 3 days and 15 hours, can be a downtime. Okay, and if it is internal tools, they're giving 999. If it is online e-commerce thing, point of sale thing, okay, 99.95. So these are the reliability metrics that they're actually are the SLAs or SLOs that they're actually able to share. Okay, and you can go with that details. Okay, if you want to go. Same thing, performance efficiency. Okay, so there are various things that they can actually look at how performance hours is your particular solution. Okay, and what are the various things that you can actually look into. So basically, performance is definitely going to be one of the major issues when you are sharing your compute, right? When you're sharing your infrastructure, there are too many things using the common compute, and then obviously there will be some bottlenecks. So how are you going to handle such bottlenecks? Okay, all these things will be answered here actually. So definitely it's going to provide high performance. Cost optimization, this is the major advantage. Obviously, it's going to reduce almost 80% of your operation cost if you are directly moving from on-prem to this public cloud offering. Okay, and it depends on the various services that you're going to use. And sustainability is one of the things that environmental impact is what they're calling it out, right? So, what is the environmental impact? Because this carbon emissions are more the more compute you have, right? Obviously. So, the more, let's say you have 100 different servers with 1 terabyte each versus 10 terabyte one server. Okay, so obviously this 100 different compute is providing more carbon emissions. Okay, that's where what they're claiming is they're contributing to the sustainability of the earth also by reducing the carbon footprint, because having all the companies come and use one common infrastructure versus everybody building their own infrastructure. So those are the additional advantages. Okay, so uh, before we wrap up, I just wanted to take you all through various services provided by AWS. Okay, let's have a quick look at what are the various services, okay, provided by and the most important thing, the primary thing, which is nothing but our servers, is EC2, which is nothing but our infrastructure as a service, and it can also offer the platform on top of it. EC2 is a virtual servers. Okay, uh, let's look into the console home and then we'll be able to. I think this is the one. Yeah. Okay, so it's giving all our recently used services. So if you look at this left side, okay, so and also these are the various important services that you have. So EC2 instance, the basically the compute. So whatever the AWS is offering, the primary thing is compute. Okay, that compute in the sense all the servers that we use actually. And on top of the compute, AWS also provides various additional analytics. For example, it can tell you, okay, how is your user pattern for your application. Okay, and that means, let's say you are building an e-commerce application, it can actually give you the complete 360-degree view, what type of users are buying more from your application, and what's the various trends that you have, and based on that you can do some targeted marketing actually. Okay, so those things will be helpful, and also a lot of other insights it will be able to give. Same application integration, let's say you have an application which you wanted to integrate with a lot of other similar application. Let's say one of the best examples is connected commerce. You are into travel business but you wanted to provide some rewards based on your credit cards. Okay, that's another thing that you can actually think of. AR, VR. So virtual reality is becoming like huge nowadays. So if your application wanted to have a AR, VR facility and wanted to leverage this cloud facility, yes, they already have a AR, VR offering, and you can develop the applications directly here. Cost management is another thing which we have already seen, that how you can manage your costs, how can you optimize your costs. Blockchain facility. So if you are developing some blockchain use cases, you can leverage the AWS platform. Same business related application. There are some predefined pre-existing business application that you can use. Compute, we just talked about already. All the servers, the elastic containers, elastic compute that you we just talked about. Okay, this is another thing. Containers. Okay, so we'll talk about containers in the course. We'll talk about Docker, Kubernetes, and all this. But definitely that's another thing that's actually happening a lot. Okay, nowadays, and there are a lot of container offerings here. And customer enablement, how are you going to increase your customer base, and how are you going to enable your customers with the best features. There are some customer analytics. If you are moving towards a product based organization, these are something that you can leverage to understand your customer base. Okay, to basically design your products properly. Okay, focusing on the customer excellence basically. Databases, we talked about it. Developer tools, the IDEs and all, are the command line interfaces that we can actually look at. Okay, end user computing. Okay, especially end user computing in the sense, let's say you join a company. Okay, you will get something like a VDI, virtual desktop. Okay, and all these things can be provided by AWS also. You don't need to create your VDI instances. You can seamlessly give these things to your users basically. Okay, and web applications and mobile applications that you can actually deploy and then use. Game developments, if you are someone who wanted to leverage a platform to develop the games, that's something. IoT, if you have IoT related applications, there are a lot of tools or the internals available to develop IoT. And machine learning is huge. Okay, it's not only just developing some machine learning solutions, but it will also apply its own AI, augmented AI will give you some recommendations also. And AWS Depracer is one of the very famous events that AWS conducts. Basically, they will actually ask various developers and like across the world, okay, uh, to develop some models. on a race tracker basically. So basically, they will give you a bot, okay, a virtual bot and a race track, okay. So you need to develop a bot in such a way that it will actually beat all other bots and then should be the fastest actually. And last year, the first and second places are actually acquired by Hyderabad folks, okay, in the entire world actually. And this year the tracks are named after them actually. So that's another good thing what AWS does, and there are a lot of other features like that. Management and governance, it's all about the licensing and any issues, okay, all this stuff. And media services basically, if you are, let's say, into the media services, even the let's say you want to develop something like Netflix, okay, or Amazon Prime, you can actually leverage this service, okay. And or maybe you wanted to run your own YouTube channel, or you want to run your own media channel, so you can leverage some of these things actually. So migrations and transfers, okay, networking and content delivery, basically you can use the gateways and everything. Quantum technology is another thing. There are very few companies who has a quantum computing backend available. Amazon is one of them. Okay, very few companies, because a huge investment, and it will take another decade or so to make it a realization and let everybody use quantum computing. But Amazon already has something, okay, to provide that entire quantum computing platform as a service, so that you can start experiencing and developing the applications on top of it. That's called bracket. Okay. Robotics, the RPA, okay. So AWS has its own flavor, which is called Robomaker, okay. Just like UiPath and others thing, okay. You have your own AWS flavoring, okay. And the satellite communication, okay. I think this is another thing that they have recently launched, okay. Ground stations, basically. You can, if you want to provide this satellite network connectivity and communication, you can use this platform and then bring your hardware to really connect to this entire network. And overall the security, identity, and all the compliance things we talked about, the regulatory and compliance thing, so it will take care of all these things. And most importantly, the storage. S3 is one of its famous storages, where it is highly scalable, where you can store huge amount of data and everything, okay. All these things are actually the various offerings. So in the course, what we will go through is some of the things that are related to our applications. Let's say you have robotics, quantum computing, and all these things probably will not go through. But whereas how an application is going to work, how can you use some of these, EC2 will be primary focus that we will be putting on the containers and elasticity and all these things. So what we will do is we will actually take a sample application, a microservices application or something like that, and try to leverage this AWS cloud computing EC2 instance and scale it in a couple of instances, create a load balancer, okay, and leverage container services and see how it's going to work in the entire gamut of, okay, this cloud. Okay, so that's what we are going to look at in the actual sessions. Okay, I'll take a pause. Any questions from anyone before we wrap up? Okay, thanks everyone.